Okay, guys, it's 4:30 p.m. here in New Delhi, India, and I'm really excited to welcome you to this webinar on electric vehicles. Thanks for being here. First of all, the topic for today is the steps you can take to be a successful EV engineer. So take some time and introduce yourself in the chat window so that everyone knows what you're up to and what you're working on, what your interests in EVs is. So take some time to introduce yourself in the chat box. I'll start with myself. I'm Akshay, and I'm the founder of MakerMax. And MakerMax is bridging the gap between the industry and the academic institutions. And it's doing this through hands-on courses and products. So before I founded MakerMax, I was actually working for Tesla for 3 years in California. And I was part of the battery team, the battery hardware team, as well as the battery firmware team. And the picture you see on the left was my lab, where I spent many sleepless nights working on the Model S, Model X, and Model 3 battery packs. And what I wanted to do is I wanted to take all that information that I've learned in the industry, as well as especially my experience at Tesla. I wanted to condense it, and I wanted to really make a big difference in the education space and reduce that gap that we have all experienced between the industry, between what we have, where the industry currently needs, and what the academic institutions like universities, colleges, and schools really train us for. So that was my segue into MakerMax. But today's topic is going to be on electric vehicles. So as we all have seen and heard in the news, the adoption rates of electric vehicles is increasing year over year. And why is that happening? Well, the future is sustainable, and the future is for a shared economy. So let's talk about sustainability first. The internal combustion cars are pretty complex, like their technology is pretty complex as compared to electric vehicles. So they inherently have a technological disadvantage in the sustainable future. This is because the internal combustion cars are struggling by making their technology even more complicated to be more fuel efficient and to reduce their emissions. Whereas electric vehicles are inherently sustainable, inherently no pollution free, and they're actually pretty straightforward to design, to manufacture, and even for the end consumer, they're pretty straightforward in terms of maintenance. So they pose a huge technological advantage as compared to internal combustion cars. As well as the second thing I was talking about is the shared economy. And we've seen that with companies like Uber and Lyft, that in the future, very few people will actually own a car. And the electric vehicles are kind of in the forefront of this shared economy with their autonomous development of driving, of self-driving. And you've seen that happen at Tesla. You've seen that happen with other cars as well. So a lot of investment going into that area as well. So what I want to say over here is that the electric vehicles have a huge technological advantage in the way we're headed towards the future. And very soon, we're going to see an inflection point in their adoption rates, and there's going to be a huge increase in their adoption. And what that means for us as engineers, as consumers, is that we need to, if we want to be a part of this revolution, we have to do it now. We have to take our first steps now. One of the very common questions I get is, how can I be a part of this electric revolution? And the answer to that is, actually, it depends. It depends on where you are. So for example, in India, there's 3 million electric three-wheelers, or we call rickshaws, that have silently just kind of made their way to the roads. So they're part of the electric revolution in India. And the electric two-wheelers are following very fast. But electric cars are not doing so well in the Indian market. If you go to the North American continent, electric cars are what is leading the electric revolution, and electric two-wheelers and bikes are not doing as well as the cars are. And if you go to Europe, the European subcontinent is about how do we make the next innovation in the component level, in the powertrain level. Whereas in North America, it's about how do we integrate it into better final customer solutions. So depending on where you are in the world or where you want to be in the world, the part that you can play in the electric revolution is going to be different. And apart from that, EVs are not just a product. So in internal combustion cars, the whole of the technology lies in the car itself. Whereas in electric vehicles, yes, the technology exists in the car, but the technology also exists in the ecosystem. And what I mean by that is that if we take the ecosystem as rings, the first ring would be the product. And the product is your electric car, your electric scooter, your electric three-wheeler, your electric skateboard, truck, you know, all these electric end consumers and end consumer products are what are the inside ring of the electric ecosystem. The next ring is fuel. And with electric transport, the fuel is not our conventional fuel, it's electricity. And what comes with that in the ecosystem is charging stations. And even in charging stations, we have fast charging stations or your home charging stations, induction charging stations, and battery swapping stations. And if we move away from the charging, we also have to look at how do we get the electric grid ready for huge amounts of charging that's going to happen every day. So all these challenges lie in the second part of the ecosystem, which I'm terming as fuel. The third part of the ecosystem is the support system. And this includes education. One of the things, education of the end consumer. Why electric cars are the future, why electric cars are better than internal combustion cars. How can we mitigate things like range anxiety? How can we make electric cars more favorable with offering things like free charging or offering things like free parking or premium parking, you know, things like that. Or in North America, there's things like offering electric cars access to the high occupancy lanes, which lets you just zoom past the traffic. So these solutions are part of the support system. Also, MakerMax, for example, which is in the education space of engineers who want to work in the electric space, is also part of this support system, part of the ecosystem. So this is the third ring in the electric ecosystem, and the fourth ring is policy, and this is where the government comes in. So government and countries, states. So this is where the high-level thinking comes in terms of, okay, how do we partner, for example, with different countries for different technologies, or what types of mines or resources should we be buying? Should we be buying lithium mines or cobalt mines so that the battery production is assisted? And so these are decisions to be made on the policy level. Even things like subsidy. So how much subsidy needs to be offered for electric vehicles to be considered in the consumer's eye as a valid price point? So this is the kind of policy side of the ecosystem. So I've explained four main areas where contribution can happen, and it's not just the product, right? You've seen there's a lot more that goes into it, and it needs engineers, it needs designers, it needs policymakers, it needs a whole array of people to make this a sustainable future for electric transportation. So one of the things, for example, you decide, is, okay, I feel like I can contribute the best in the product space. That is the part of the ecosystem that I want to be part of. So once you've decided that, many times I've heard people say, oh, but if only I had a really nice lab to work in, if only I had the right equipment. I feel like I don't have the right equipment to work with, and so I can't really contribute. And I've also heard people say, oh, if only I had a nice job that would teach me this. You know, I'm looking for that perfect job in the electric space that will teach me how to work with electric vehicles. And then I can start working on my project. Well, what I'm here to tell you is that you have to start lean, you have to start simple, and you have to be flexible. So this is actually a picture I took just this morning of my lab setup that helps me work on batteries. So over on the left, you see a simple soldering station. In the middle, you see a DC power supply, and you see an oscilloscope that helps me see waveforms. You see a multimeter, and I would say the fanciest part of the equipment I have is a discharger, and that lets me discharge at a constant voltage or constant current. So you can see that, I mean, I built this over many years, one at a time, and not everything is purchased new. I looked around and I saw, okay, different deals happening to get what I needed at whatever time so that I can start working on small projects. And I started this way back, many years back, starting with just small things and starting working on small projects and growing up from there. So what I'm trying to say is you have to start simple. If you wait for the perfect moment to come, that's going to be too late. So say you start simple and you're like, okay, Akshay, I see what you're saying, and I still want to work in the product space, and I have this really great idea, and I want to work on a trackable solution for a BMS system. And I'm like, okay, great, that's great, but that's a huge goal. Let's break it down. So if we break it down, for the trackable BMS solution, we have the BMS side of it and the trackability side of it. Now, I would argue that the BMS side of it would be a harder market to get into because there's already so many BMS solutions out there. But still, if that's something you want to do, then you have to think about, okay, am I going to be working in the battery electronics space where I'm going to be working on the hardware, or should I start targeting the firmware? Should I start targeting better algorithms for state of charge, for health, those kinds of things for the BMS? Or if you decide you want to be targeting first on the trackability side of it, then you have problems to solve like, okay, how do I get the data from the device to the cloud? How do I upload it to the cloud? And how does someone view it in a good format, in a graphical format, in an easy to read format from the cloud? And secondly, how do I program the device itself, the tracking device? How do I program the firmware for it? And third is the technology integration. With that, I mean, you have to think about, will it be a GPS solution? Will it be a Wi-Fi solution that also works indoors? Or will it be one of the newer technologies in IoT? So these are challenges that you would have to tackle on the trackability side. So with this, I want to tell you that when you've decided to start lean, you also have to break down the problem that you're working on simple, smaller problems that can be addressed and can be gotten to in a short amount of time, and you can get market feedback, customer feedback on them, and start iterating on your designs. This is the only way to get forward, and this is the only way to get your feet wet as soon as possible. Now, the one thing I've not talked about so far, so just a quick recap, we've talked about first that the electric automobiles or electric revolution is an ecosystem, and you have to choose which part of the ecosystem do you want to be a part of. The second is that you want to start lean. You don't want to start with a big idea. You want to start with smaller ideas that you can execute and test. The third is that a lot of times when you start working on your idea, it's inevitable that you're going to hit some roadblocks. And that roadblock might be a technological roadblock, or that roadblock might be just motivational roadblock. So this is where a motivating virtual learning environment, or even a non-virtual learning environment, would be very useful. To be around people that think like you or that have the same goals as you is going to be very useful and very helpful. The second is expert mentorship. When you need help, you have experts by your side to guide you through the problems. And this I've seen through research and through my self-experience that it accelerates the process more than 10 times. If you have the right people around you to help you through the problems, then your projects are it's inevitable that they'll succeed 10 times more likely to succeed than other projects. And lastly, it always helps to have a structured learning approach. So if you're learning something, if you're going all over the place, I'll learn this too, learn that too, and then maybe somehow it'll all fall down together, then usually just, even if it does happen, it takes up much more time than it should have. So a structured learning approach is what we've seen really, really helps through the process. So at MakerMax, with electric vehicles, there's basically electric vehicles as a marriage of embedded systems and power electronics. And this is what we want to bring together. This is what we're bringing together with our courses and products, so that these three things are satisfied. You can see which part of the ecosystem you want to work on. Secondly, you can see you can operate in a lean basis. You can make projects and learn from it very quickly. And third, you have a learning environment which is motivating, and you have mentors by your side. And one such course that we've found has done really well is the masterclass on electric vehicle batteries and BMS. And this is something I've iterated on more than 4 or 5 times. And now we've gotten to a point where it's it encompasses all these values that I've talked about so far. Because with BMS development, it's not just about this huge goal of making a BMS. We start small, and you have to start making those small things. For example, if you were learning about batteries, you would first, let's think about how can we learn about one cell, like one lithium-ion cell. Do we know how to make a management system for one cell? If we do, yes, then let's go on to 100 cells. And if we know 100 cells, let's go on to 1,000 cells. But if we don't, let's learn that one cell first, right? So this is the structure of the courses that I've been making, and I encourage you to do this even in your own learning patterns. You take a big problem and you break it down into smaller pieces and attack them. You'll see that it gives you a lot more motivation to get to that bigger problem, and a lot faster as well. So the other thing I told you about was that you have to start making projects, you have to start doing hands-on work. And this is something I imbibe even in the courses and the products that we sell. And it's all about how we can get learning in a hands-on manner with not much investment to start with. So we can learn and we can iterate on our ideas as soon as possible. So I wanted to give you an kind of insight into what it looks like. One of the things that I also talked about was mentorship and iterating on our ideas, right? So you can see a picture over here of what the inside of our battery masterclass looks like. And you can see, for example, in week 5, we learned about different characteristics that a lithium-ion battery goes through. How does the lithium-ion battery discharge? How does it charge? And what kind of capacity degradation happens? What are things like hysteresis that happen, the phenomenon that happen in lithium-ion batteries? So we learn about that, and then we go through a quick quiz to do a quick checkup on, okay, what did we learn, what did we not learn? Let's get quick feedback on that. And then we do a discussion between not just the instructor and the student, but between different students from all around the world and different disciplines as well. So that kind of learning is what I was talking about before, where you learn a small concept, you quickly test it, and now you're discussing it with a bigger group, which is going to give you very quick feedback on what you did wrong, what you did right, and what you can improve. So this is what we imbibe in our classes as well. So I just wanted to summarize what we learned today. The first thing we learned is there's a huge growth in electric vehicles, and the time to be part of it is now. because the inflection point is just around the corner where they're going to take off. So if it's not already too late to be a part of it, I would say that your first step should be today. The second is that it's a huge ecosystem. You shouldn't be worried, okay, I'll be just making, I want to actually just make a BMS, or I want to make a motor controller, or what have you, right? Like not just the end product, there's the 4 rings we talked about. There's a huge ecosystem that needs to develop, and the opportunity exists throughout the ecosystem. And we also talked about how the opportunities are different depending on where you are in the world. The third thing we talked about is being lean and being flexible. We start with simple projects that we're motivated and we can kind of see how we can accomplish that. And we start with those and we start iterating on those. So that is about starting lean and being flexible. And the fourth is finding a learning environment that motivates you, which the only way to do that is to be around like-minded people, people that inspire you, people that think like you, people that would be happy if you grow as a person. And mentors who've been there, who've done that, who know how to guide you when you go wrong. And lastly, this is the time to invest in yourself, right? And when the opportunities come to your door, you have to be ready for it. And the only way to do that is if you invest in yourself today. And once you do find yourself in a position where you're ready to teach others or ready to share your skills with others, that's the point of when you can start paying it forward, because giving is just another way of learning as well. So that's my summary for today. There's a question about building our own products. Yes, currently we're making educational products. And we're making, for example, we have a custom board that teaches students I2C protocols, and we have a custom board on BMS solutions, so lithium-ion cells, how to learn everything there is about one lithium-ion cell. So we are a custom educational product on that, and we also have products coming up on DC-DC converters and also on motor controllers. So yeah, a lot of work going on in the product space for sure. Okay, great, guys. Thanks so much for attending, and I'd be happy to speak. You have my contact information. I'd be happy to speak further if you have any questions following this webinar. And yeah, just as an announcement, I want to let you know that we have our battery masterclass that's going to be starting on the 20th of November, and we have our embedded masterclass that's starting on the 10th of November. So hope to see some of you there, and I hope this this webinar was an exciting exciting discovery for you, that there's a lot to do in the electric space, and I really hope for you to be part of it. So thanks for attending, and yeah, hope to speak to you soon. Take care.